Britain just finished its second warmest July on record, and instead of easing into a typical late summer, the country walked straight into another heat wave. With temperatures climbing toward 36 degrees Celsius in parts of England and Wales, 5 separate regions have officially been declared in drought, and wildfire warnings remain active across multiple counties. Hosepipe bans are still in place for millions of households. And behind every single one of these headlines sits the exact same culprit: a ribbon of fast-moving air, roughly 5 to 7 miles above your head, that meteorologists say has settled into a position they consider genuinely dangerous for the United Kingdom. Understanding exactly what that ribbon of air is doing right now, and why scientists are so concerned about where it keeps parking itself, reveals something far bigger than just another hot summer. That ribbon of air is called the jet stream, a fast-flowing river of wind that circles the entire planet high in the atmosphere, forming where cold polar air collides with warmer air from the tropics. For Britain, this jet stream matters more than almost anywhere else on Earth because the country sits directly along its typical path across the North Atlantic. When the jet stream sits north of the UK, high pressure tends to dominate, bringing settled, dry, and often unusually hot conditions. When it sits south of the country, or directly overhead, it drags a conveyor belt of Atlantic storms straight across Britain, bringing wind, rain, and unsettled weather that can last for weeks at a time. The exact position of this single ribbon of air, sometimes shifting by only a few hundred miles, is the difference between a gentle British summer and the kind of extremes currently gripping the country. Right now, that position has become deeply unusual. Following an exceptionally dry start to August, high-pressure systems re-establish themselves firmly across southern and central Britain, effectively locking the jet stream well to the north of its typical summer position. Meteorologists have explained that this setup allows southerly and southeasterly winds to tap directly into hot conditions already baking continental Europe, dragging that heat straight into England and Wales, while Scotland and Northern Ireland remain caught on the cooler, wetter side of an increasingly stark north-south divide across the country. This is not simply a warm few days passing through. It is a persistent atmospheric pattern that has effectively been locked in place for weeks. Here is why meteorologists describe this particular configuration as genuinely dangerous rather than simply inconvenient. A jet stream locked firmly to the north allows high pressure to sit stubbornly in place for extended stretches, and stubborn high pressure means no rain, no wind, and no relief. Water companies and regional authorities have already warned that this renewed spell of extreme heat is actively worsening drought conditions across southern England. Conditions serious enough that on August 10th alone, official drought status was declared across the East Midlands, Lincolnshire and Northamptonshire, Kent and East Sussex, and the Solent and South Downs region. Reservoirs are dropping, rivers are running low. Crop harvests across multiple counties are now considered at severe risk of collapse, with farmers watching fields that should be thriving in late summer instead struggling under conditions more typical of a genuine agricultural emergency. If a story like this genuinely makes you want to understand exactly why the jet stream has become so unpredictable in recent years, hit that subscribe button now, because the science behind why this pattern keeps locking into place reveals something deeply connected to a warming planet. To understand why this jet stream pattern has become so persistent, you need to understand what actually powers it in the first place. The jet stream exists because of temperature contrasts, the sharp difference between cold Arctic air and warmer air from further south. That contrast is exactly what creates the pressure gradient driving the jet stream's powerful winds. But climate change is steadily eroding that contrast because the Arctic is warming considerably faster than the rest of the planet, a phenomenon scientists call Arctic amplification. As the temperature difference between the pole and the tropic shrinks, the jet stream itself weakens and becomes noticeably more wavy, meandering into much larger loops and dips, rather than flowing in the tighter, more predictable band it once followed. This waviness matters enormously for exactly the kind of locked-in weather pattern currently gripping Britain. A weaker, wavier jet stream tends to move more slowly, and when it forms a large ridge or loop, that ridge can effectively become stuck in place for days or even weeks at a time, a phenomenon scientists refer to as atmospheric blocking. Instead of weather systems moving through in the typical few days, they stall out entirely, allowing whatever conditions have settled in, whether blistering heat or relentless rain, to simply persist far longer than they, historical eye, would have. This is precisely the mechanism researchers point to when explaining both Britain's increasingly common summer heat waves and, at other times of year, its increasingly persistent stretches of stormy, rain-soaked weather. That second half of the equation matters just as much as the current heat. Earlier this year, Digest meteorologists documented the jet stream sitting further south than typical for the season, steering a relentless conveyor belt of wet and windy Atlantic storm systems directly toward the UK for weeks on end. Exactly the kind of extended wet spell climate scientists have been warning would become more common as the planet continues warming. In other words, whichever direction this increasingly wavy jet stream happens to lock into north or south of the country, Britain now finds itself facing genuinely extreme conditions for far longer uninterrupted stretches than it experienced throughout most of the 20th century. Scientists studying this shift describe it using a term that sounds almost too simple for how serious the implications actually are: weather whiplash. Instead of a gradual, moderate transition between seasons, Britain increasingly lurches between prolonged extremes. A punishing multi-week heatwave E and drought followed, sometimes within the very same year, by weeks of relentless flooding rainfall once the jet stream's position finally shifts again. Each extreme on its own would be manageable. It is the increasing frequency, duration, and severity of these locked-in patterns that genuinely worries researchers tracking Britain's changing climate. Researchers studying the jet stream's growing waviness have also pointed to another unsettling wrinkle in this picture. A slower, more meandering jet stream does not just create longer-lasting blocking patterns over Britain specifically, it tends to create matching opposite extremes elsewhere along the same wave, meaning a persistent heat dome parked over one region often corresponds to unusually cool or stormy conditions sitting downstream. That is part of why Britain's current heat wave has coincided with sharp regional divides, even within the country itself, with Scotland and Northern Ireland catching persistent rain and cooler temperatures, while England and Wales bake under record-breaking heat just a few hundred miles away. Some climate scientists have gone further, suggesting that this same wavy jet stream mechanism may be contributing to the kind of simultaneous extreme weather events now being documented across entire hemispheres. Heat waves in one country arriving at almost the exact same moment as flooding or cold snaps thousands of miles away, all connected by the same disrupted atmospheric river of wind circling the globe. Historical comparisons make the scale of this shift even clearer. British summers throughout much of the 20th century rarely produced consecutive heat waves stacking directly on top of each other within the same season, the way this year's pattern has unfolded following what was already the second warmest July on record. Meteorologists tracking decades of data have noted that instances of the jet stream locking into a stable blocking position, whether bringing heat or persistent rain, have become measurably more frequent in recent years compared to historical records stretching back generations. That trend lines up precisely with the broader pattern of RT amplification, steadily eroding the temperature contrast that once kept the jet stream flowing in a tighter, more predictable band across the North Atlantic. And what makes this particular summer's pattern especially notable is how it has unfolded almost like a two-act play across the same season. Earlier weeks brought an exceptionally dry start to August, even before this latest heat wave took hold, meaning soil moisture levels were already critically low heading into the current spell of extreme heat. That compounding effect, drought conditions, setting the stage for an even more damaging heat wave layered directly on top, is exactly the kind of interaction climate scientists have been warning becomes more likely as blocking patterns grow longer and more frequent. Dry ground heats up faster and retains less moisture to cool the surrounding air, meaning each successive locked-in dry spell can actually intensify the heat that follows it, a feedback loop that makes recovery increasingly difficult without a genuine, sustained shift in the underlying weather pattern. The practical consequences of this locked-in summer pattern are already stacking up in ways that touch nearly every part of daily life across the country. Firefighting crews have been stretched thin, responding to wildfires sparked by tinder-dry vegetation across multiple counties, prompting renewed calls for Britain to build what fire safety experts describe as a genuinely wildfire-resilient society, one where prevention becomes a shared responsibility rather than something left entirely to emergency services. Public health authorities have issued heat health alerts across the southeast, warning vulnerable populations about the dangers of prolonged high temperatures. Even Britain's wildlife has felt the strain, with researchers documenting the hidden toll heat waves are taking on fish populations, struggling in warming, oxygen-depleted waterways, while naturalists have puzzled over noticeably fewer wasps this summer, one small but telling ripple effect of a season behaving nothing like the ones British ecosystems evolved to expect. Farmers are facing perhaps the most immediate and financially painful consequences of this locked-in pattern. Crop harvests across drought-declared regions are now considered at severe risk of collapse, threatening yields for staple crops at a moment when reservoirs are already critically low and irrigation restrictions are tightening across affected counties. Agricultural experts warn that a single locked-in dry spell arriving at precisely the wrong point in the growing season can undo an entire year's worth of careful planning, regardless of how well a farm was managed through the calmer months earlier in the season. Meteorologists are careful to note that no single heat wave or drought can be attributed entirely to climate change on its own, since weather has always contained natural variability. But the pattern researchers are documenting across multiple consecutive years a jet stream growing measurably weaker and wavier, locking into blocking patterns more frequently and driving longs. More extreme stretches of both heat and rain fits precisely what climate models predicted decades ago as global temperatures continued rising. Understanding the jet stream, in other words, has become essential not just for tomorrow's forecast, but for understanding the entire trajectory of British weather moving forward. For now, life across much of England continues under blazing late summer sun, beaches crowded with people seeking relief from the heat, farmers anxiously watching cracked dry fields and reservoir levels tracked daily by increasingly concerned water companies. Meteorologists continue monitoring exactly how long this current locked-in pattern will hold, and exactly when, or if the jet stream will finally shift back toward its more typical late summer position, bringing the cooler, unsettled conditions that have historically marked the transition into autumn across the British Isles. Until that shift arrives, the same ribbon of high-altitude wind that has quietly shaped British weather for as long as anyone can remember remains locked exactly where meteorologists least want to see it. If this story changed the way you think about the weather outside your own window, make sure you like this video and subscribe, because we cover the atmospheric science shaping the extremes so many people are living through right now without fully understanding why. The jet stream may be invisible to the naked eye, but its position, locked firmly in place for weeks at a time, is quietly rewriting what a British summer actually looks like, one dry reservoir and one cracked field at a time. Stay alert, stay informed, and I will see you in the next one.